Check it out. Captain America is partly inside of hyperbolic space. Let's put him completely in hyperbolic space. The Incredible Hulk does not like hyperbolic space. He's trying to get rid of it. And he can't get rid of hyperbolic space. He's stuck with it. So Captain America is going to help us with our hyperbolic space problem today. We have constructed, Captain America and I, a hyperbolic triangle that is singly asymptotic. I have an angle of 0. I also used the radius of the space to create a 60-degree angle here. I used the same size compass as I did to make this circle to make this 60-degree angle. So there's an undrawn equilateral triangle here. So I've got a 60-degree angle. I've got a 0-degree angle. This is 60 right there. And because I constructed the hyperbolic or the center of this hyperbolic line is on here, that makes this 90. So I have triangle OAB is a 90, 60, 0 triangle. I know the size of the angles, which means I can find sizes of sides. Well, 2 of the sides are already known. The hyperbolic length of AB and the hyperbolic length of OB are already known. And questions like this stayed open on last week's wiki. I was surprised. What is the hyperbolic length of a hyperbolic ray? It is infinity. Rays go on forever. The hyperbolic length of OB is also infinity. So I'm just going to write AB, OB have infinite hyperbolic length. So I'm not going to use any formulas to go looking for them. I already know what they are. However, Captain America has spied the one side of the triangle that is finite. OA is of finite length. I wonder if we can find it. Well, we'll have to slide the Hulk out of the way because he's blocking this formula, but he can hold it up. This is Formula 2 from page 86. And if you look at Formula 2, it has a little c and an uppercase C. The uppercase A, B, and C stand for angles. Lowercase stands for side length, and it stands for hyperbolic side length. And that is our friend hyperbolic cosine. So this formula is right out of the book. It's for triangle ABC with side length, lowercase a, lowercase b, lowercase c. There's a picture in the book. Now let's apply this formula to our triangle. And here's what we get. The only side we care about is side OA. Now what's opposite side OA? The angle B. So angle B goes here. See how little c and big C are opposite each other if you draw the triangle. This would be the side opposite angle B. And that means angle A and angle O. And please don't shoot me. I know there's several angles at A, but they're all 90 anyway. So A and O just take their parking places. And we happen to know all of those angles. Angle A is 90. The sine of 90 is 1. Angle O is 60. Sine of 60 is square root of 3 over 2. Cosh of OA, the thing we're looking for. Sorry, we'll get it in the picture there. Cosh of OA, the thing we're looking for, equals 1 plus the cosine of 90 is 0. So I don't even care about the cosine of 60. That's all 0 there. So I find that the cosh of A is equal to 2 over square root of 3, and that's the nice answer. However, if you want to know the hyperbolic length, you have to do the inverse cosine. The inverse cosine. Let's see if we can get that on camera. Inverse cosine of 2 over square root of 3. So you have to go using the catalog button that's in blue here just to find inverse cosine on your calculator. So that's the hyperbolic length of this one side. So now we would know all 3 sides and all 3 angles, but how weird is it that we have a geometry where 2 of the sides are infinite and 1 of the angles is 0, but we're still talking about it as if it's a triangle. All right, one more example with our friends Captain America and the Hulk. This one, we're going to do some of the drawing ourselves. We could use some more experience with that. Now what I've done here is, here's hyperbolic space again. There's O, the center of our space. And I have done that same equilateral triangle trick. So let's put Captain America standing there. He looks heroic. That equilateral triangle trick where I've made a an undrawn equilateral triangle here and one here. So this angle right here is 120. Now what I'd like to do is make a hyperbolic line that goes through each of these points, and those points are special because I did the perpendicular bisector construction twice. I did the perpendicular bisector of this radius, so that's a half. This is 1 in Euclidean length. This is 1 in Euclidean length, so that's a half. From O to there is a half. Now I'd like to get the hyperbolic line through both of these. Well, how am I going to get the hyperbolic line through both of those? Well, I'm going to need to construct the inverse of one of them because I need to get enough information to get a circle. Well, I just happen to have my perpendicular bisector marks are still there, so I can get the perpendicular from this point drawn to there, and then I can do from the center to that point on the circle. And then I can do one more perpendicular. I'm going to use that t-square trick that my clear ruler allows me to do. Get the pen right on there. And I'm going to get a right angle. And this point here should be the inverse of this point. Let's call this A. This point is A inverse. There it is. The typical inverse of a point construction. Now I want the perpendicular bisector. I want the perpendicular bisector of A inverse, because that will have the center of any circle that goes through A and A inverse will be on that thing. So I just got to make this more than halfway. And I'm going to make some marks from A and A inverse. And there's the perpendicular bisector of A inverse. How great is that? It's that quick. It's even faster with Sketchpad. All right, so that's the perpendicular bisector of A inverse, and it is money. It is so useful because now all I need is the perpendicular bisector. Let's call this point B. All I need is the perpendicular bisector of AB. Let's do that. One more perpendicular bisector, and I know where to put the point of my compass. See how this segment's a little bit off there. I don't want it to be that bad, so I'm going to redraw. I'm going to use this right-hand marker. All right, so I'm going to do the perpendicular bisector of these guys, of AB. And I'd like to make the marks kind of out of the way here. I got a lot of stuff going on. All right, perpendicular bisector of that, and I want it to intersect the perpendicular bisector that I just did a second ago. So I hope they meet on the paper, and I am SOL. Oh, that's too bad. But luckily I can fix it by just setting up a pad of paper next to it and getting them to meet, you know, in the place where it looks like they should meet. So I'm going to just quick fix this. This is going over here. This is going over here. So that's just, I should have used a ruler. I know, I just want to get this thing done for you. That's the point, and I want to get this compass to hit both of these points, A and B. Is it going to hit both? Make it a little longer than it should. It's hitting, it's a little too long now. All right, so it's hitting B, it's hitting A. There we go. Now we have a triangle that's worth our attention. Check it out, dudes. Look at this. I'm going to emphasize it here. This is triangle OAB. And here's what we know. Let's put the Hulk right there and have Captain America looking at the triangle. Standing on like that. Oh, that looks pretty good. So this triangle here, let me shade it for you. This is the triangle we're going to find pieces of. Well, we happen to know that angle BOA was 120 because I built it that way. I don't know angle B or angle A. I know they're equal though because I have OA equals OB. So this is an isosceles hyperbolic triangle. But I'd like to find either of those angles. But that means I'm going to have to use Formula 1. And Formula 1 is the one that we use. It's on page 85. Formula 1 is the one that we use when we don't know so many angles. And it says the cosh of little c is equal to the cosh of A cosh of B minus sinh of A sinh of B cosine of the only angle involved, big C. So this tells me what to do. I'm going to put the 120 right here because it's the only angle I know. So if you look at the formula, that means I'm going to have cosh of the side opposite 120 all by itself. So that's going to be cosh of AB. So I'm going to have cosh of AB equals the cosh of little a. Now that's the angle across from, or the side across from angle A. So this is little a, this is little b. And I just happen to know that the length, the hyperbolic length of little a equals little b equals natural log of 3. We did this. We did this calculation in the book. When you have the midpoint, when you do from O to the Euclidean midpoint, that length is natural log of 3. So I have cosh of AB equals cosh of the natural log of 3, cosh of the natural log of 3, minus sinh of the natural log of 3, sinh natural log of 3, and then the cosine of 120. Well, that's a doable calculation. You can do it on your calculator, or you can do it by the definition. Let's do it by the definition. The cosh of the natural log of 3 is equal to e to the natural log of 3 plus e to the negative natural log of 3 all over 2. Well, e to the natural log of 3 is 3. This is the same as e to the natural log of 1/3. So this is 3 plus 1/3 over 2. Well, that's 9/3 plus 1/3 is 10/3. 10/3 over 2 is equal to 5/3. So that's what this is. Cosh of natural log of 3 is 5/3. Or you could do it on your calculator, but your calculator would give you 1.6 bar. You know, it's not going to give you the exact value. That's a 5/3 again. Now the sinh of the natural log of 3 is equal to 3 minus 1/3 over 2. So that's going to be 9/3 minus 1/3 is 8/3 over 2, which is 4/3. So I have a 4/3 here and a 4/3 here. Anybody know what the cosine of 120 is? The cosine of 120 is going to be the same as the cosine of 60, but the opposite sign. So that's going to be a negative 1/2. If you don't believe me, go ahead and try it on your calculator, but I'm pretty sure I got this right. So my final answer, my cosh of AB, let's put it right down here. Cosh AB is equal to 25/9 plus, because it's minus minus, plus 16/9 divided by 2. 16/9 divided by 2 is 8/9. So that would be 33/9. That's cosh of AB. We found out what this length was, this curvy side of this triangle. Well, now we know all three angles. Oh, we never did the angles. I would leave that as a possible homework problem, because now since we know all the sides, we can go after any angle we want. And that's the kind of stuff that you're going to see on the upcoming wiki and probably on the Mega Wiki. So I'm glad you watched. A little bit of hyperbolic trig for you, and how to construct a triangle that has a 120-degree angle and its isosceles. So that's kind of cool too. See you later.